Hello and welcome back to the Waters and Stanton video channel. I certainly had a lot of feedback from viewers, comments and also emails about the antenna, the dual band 20 metre and 17 metre end fed antenna, and I think there was obviously a little bit of misunderstanding about how an end fed antenna works. Now, as I said before, I've done a lot of work on end-fed antennas and they're very popular, and hundreds if not thousands of people around the world are using end-fed antennas using the matching transformer, and clearly the antenna works extremely well. It's got a lot of advantages and it's simple and it's guaranteed to work, and you don't need an antenna tuner. And if you do need something just to sort of perk it up at the edges, your built-in antenna tuner in the radio will certainly tidy it up. But I've used an end-fed antenna on 80 through to 10 metres and I don't need an antenna tuner. And this particular antenna that I came up with, the 20 metre and the 17 metre antenna, likewise doesn't need an antenna tuner. And in fact, there's some shots here of me using it in my little motorhome, and which is one of the reasons really I designed this antenna, because I wanted something I could use in my motorhome. Motorhomes are sort of fiberglass or whatever you call them, so there's not much metal work. You can't put an antenna on the, well, you can put an antenna on the roof, but there's no ground plane there. So you need something that will work when you park up, and you don't want something that's too long. And in fact, this antenna, it works out at just over 25 foot long. Sorry for those guys that are being brought up on meters. Let's say that it's about, what is it, about 8 meters long, I think, something like that, around about 8 meters long. And it's a very manageable length of wire. And I show here on the on this little video how I've connected it up. It's very simple, bit of coax cable going from the radio through the roof light. The actual transformer is on the roof of the van, and the length of wire goes to a convenient point. Now, in this particular case, the convenient point was actually my garden fence because I was not out and about, but I just wanted to test the system. I was very pleased with the IC705, which I use quite a lot. The SWR was very low. It's around about 1.5 or thereabouts across most of the band, so that's great. And I had some good contacts. And in fact, I'll put up on the screen here reverse beacon I got. I just did a couple of CW CQs just to check out what the reverse beacon reports were. Now, bear in mind that I was running 5 watts into an end-fed half wave on my driveway, and one end was around about 4-5 foot above the ground, so not an ideal situation, but it did prove that the antenna worked. And as I say, only running 5 watts, so if you double the power, then you can add 3 dB to the signal reports, and of course if you run a lot more power you'll get a lot better. So it does prove the point that you can actually have an antenna that you can run out from a motorhome or anywhere else you are. When you're running QRP, or maybe you're not running QRP, maybe you're running 50 watts, 100 watts. I know a lot of you can run 100 watts from your mobile rig, run a bit of wire out like this, and you can have some really good fun. So it works extremely well. Now, the problem comes when you imagine that an end-fed half wave will perform the same with or without a trap. It doesn't. Let me explain how this antenna works. You have a 17 metre trap, and that trap means that the length of wire between the transformer and the 17 metre trap acts as a dipole. Great. You can feed it with your end-fed transformer because it's a high impedance at the feed point, and the transformer is quite happy delivering power to your 17 metre dipole. That 17 metre trap will allow 20 metre energy to go through, no problem at all. So you then have a length of wire beyond the trap, which brings the whole system to resonance on 20 metres. That's great, no problem at all. You've got a dual band antenna that works on 17 metres and 20 metres. So why then why doesn't that antenna resonate on 10 meters? Because we know end-fed half waves work on harmonics. So if you've got an antenna that works quite happily on 20 meters, it's got to work quite happily on 10 meters, doesn't it? Well, no, it doesn't. It's not very happy on 10 meters. Let me explain why. When you put that trap in the antenna, the 10 meter energy comes up to that trap, and the coil is primarily a choke as regards 10 meter energy. It doesn't really want to let that energy go through. It acts as a choke. So immediately you've got 10 meter energy feeding into the antenna but hitting the buffers when it gets to the 17 meter trap. That length of wire is not resonant on 10 meters. But you've got a capacitor. That capacitor allows energy to go through. It allows 10 meter energy to travel on up the antenna. So surely it's going to resonate at 10 meters. No, it doesn't. And I'll tell you for why. When you insert a capacitor in series with a wire aerial, it actually stretches the antenna. So the antenna that you would expect to resonate on 10 meters doesn't. It resonates on something like 9 meters, something like about 33, 34 megahertz. It stretches the antenna, which is why you don't see a 10 meter resonance. Now you do actually see a resonance around about 33 or 34, and that's because the antenna is being stretched by the capacitor. So let's basic antenna theory. You have a length of wire and you put a coil in series with it. Provided that coil is not acting as a choke, let's assume that you've got let's say you've got a 10 meter length of wire which is resonant on 20 meters, and you put a 6 or 8 turn choke, 8 turn coil in series with it. You're actually loading that coil and you'll make that antenna resonate on a lower frequency. You're actually compressing it. So that antenna will work on a slightly lower frequency because the inductance is loading it. Take that inductance out and put a capacitor in it, you're stretching the antenna. So the antenna, which is 10 meters long and you'd expect to work as a 20 meter dipole, it doesn't, because you've stretched the antenna. It's now working on a higher frequency. So you can make a 10 meter length of wire, which is 33 feet, sorry, but apologies, that's the way I was brought up. This 33 foot length of wire, which is a dipole, put a capacitor in series with it and you stretch it. Now, the amount you stretch depends on the capacitor. The smaller the capacitor, the more you stretch it. So you can make this 10 meter length of wire resonate on 18 megahertz or whatever, depending on the value of the capacitor. So the lesson here is, as soon as you put a trap into an end-fed half wave, you disturb the harmonic relationship. So whenever you put a trap in, you've got to remember that you are going to affect the harmonic relationship. So our 17 meter and 20 meter antenna is quite happy with a 17 meter trap in. It would probably be quite happy if I inserted a 10 meter trap between the feed point and the 10 meter trap. You'd have a length of wire which is, give or take, I don't know, 5 meters long. It's a 10 meter dipole. Next bits along would resonate on 17 meters. You'd have to make it a bit shorter, and the bit beyond that would resonate on 20 meters. So you could, with 2 traps, make an end-fed wire that works on 10 meters, 17 meters and 20 meters. You could actually make that antenna work on 10 meters, 15 meters and 20 meters if you change the resonant frequency of the trap. But you have to be mindful that only certain combinations will work. I'm not sure whether I've explained that very well. I hope I have, but certainly there was a lot of confusion, and I'm going to do some more experiments with traps. I've got some other ideas. You can sort of fiddle about with traps in end-fed antennas. End of the end of the story is that end-fed antennas are great antennas. As soon as you put a trap in, you've got to think about it, because things start to happen. Okay, well, it's a very short video really, but I wanted to sort of clear this up because there's a lot of misunderstanding about this, and I didn't want sort of people to sort of scratch their heads and not get the answer. I mean, I try to answer the emails and the comments, but I can't answer them all because sometimes there's just too many, and a lot of the time I will be repeating myself. So thanks for watching this very short video, and I hope you enjoy the coming weather, which I think can only be better. I was working a station in Austria on the wire actually, and I had a heat wave in Austria. Likewise, in somewhere in Russia, UA3TCQ I worked, and he said the temperature there was 33 degrees. Well, we could do with some of that at the moment, couldn't we? So enjoy your ham radio, take care, and speak soon.